This is the whiteboard mode I had spent days trying to achieve, and it's finally here. But you might wonder, what exactly is a whiteboard mode? I'm going to explain that to you in a moment. The year was 2020, and because coronavirus was spreading like wildfire, a lot of people around the world were forced behind closed doors. This means most of the things we normally do and our daily activities had to continue, but then online. In other words, almost everyone around the world was working remotely. And because majority of people were working remotely, this means the tech world had to make some new innovation. Most of this focus from the tech world was on the webcam and video conferencing software such as Zoom and Skype, which means lots of features and improvements had to be added to webcam and video conferencing softwares. One of the features that was added to the webcam was the whiteboard mode, which is what we are discussing in this video today. So what exactly is the whiteboard mode? Imagine you were teaching a class online and you have to explain something on the whiteboard. Most of the time, you have to adjust your webcam to focus on your whiteboard and to get the right angle so your audience can gain and see some of the things you're writing on the whiteboard. But what the whiteboard mode does, it looks for the whiteboard in the room all by itself, it recognizes it, and it also cuts out the rest of the frame, leaving only the whiteboard. It does not matter if the whiteboard is bent at an angle. The whiteboard mode will always return the whiteboard back as a perfect 2D image, so the audience can see most of the things you do on the whiteboard. There are lots of advantages to the whiteboard, which makes it very good and very practical to use. But as you might have guessed it, this came at a price. It is very expensive, which means I need to find a solution. And what solution did I find? Well, I tried building mine. I tried building what took paid engineers maybe months to make and give it to the world for free, which is the main purpose of this video. So let's get started. For anyone familiar with programming, it is no-brainer to know that for this project, you will need to use computer vision. But the problem is I do not know computer vision, which means I first had to learn computer vision to make this project a success. So I went to YouTube and I searched on courses for computer vision. I found a 3-hour video on freecodecamp.org and I watched that 3-hour video for 2 good weeks. Now I have the basic knowledge of computer vision, and let me explain to you the hard part of this project, or exactly how I am going to deal with this project. In this project, my webcam will serve as the eyes of the project, looking at everything in the room, and then everything the webcam sees will need to be processed by something I call the brain of the project, which is an AI. So whatever the webcam sees will be sent to this brain, and it is the brain that will process or decide if it has detected a whiteboard and what to do with what it has detected. And the next step will be to deploy this brain onto my system. After deploying it, it should give me a output. One problem is already solved in our project. We have a Logitech C270 webcam, and you can even use your laptop webcam. Now onto the second part of the problem, which is the brain, and which means I need to train a computer vision model to recognize a whiteboard. I have never trained an AI model, but with the help of courses online, I was able to know how to train an AI model. Think of training an AI model as taking a kid to the school for the very first time. There are various ways and methods to which you can teach a kid, and this is so true with the AI, because you have to decide of a way you are going to teach your AI to recognize something. Now, the webcam is capturing tons of information around its environment. In a room, it will capture the window, the walls, and every other thing you have laying around. The decision is left with you how you teach this AI, which is the brain of the program, to look at the footages being captured by the webcam and decide which things in this footage is a whiteboard. Now, to teach this AI, I could get bunch of pictures of whiteboard and tell it to the AI, this is a whiteboard, but this is not a wise decision, as all whiteboard around the world do not look the same, and this will end up giving errors as the AI will not recognize all whiteboard. There are different ways you can teach this AI. For my level, I wanted to keep it simple, so I had to go with these stickers. Instead of training the AI model with pictures of a whiteboard, why not train it with pictures of these stickers placed on all four corners of the whiteboard? Now, even if you have a whiteboard of dimension of 10 by 10, as long as you have these stickers on the four corners of the whiteboard, the AI model will have no trouble recognizing it as a whiteboard, and any other things in the room that bear resemblance to the whiteboard, as long as they do not have these four stickers on their corners, the AI model will not recognize them as a whiteboard. So I designed these stickers on Photoshop and went on to train my prototype model to understand exactly what I am getting into and what I am actually doing. And also, I didn't just train the model to recognize these four stickers at the corner of the board as just stickers. I actually labeled all of the stickers as the top left sticker, top right, the bottom left, and the bottom right stickers, which also has a couple of advantages, as you will see in the video later. I edited my dataset using RoboFlow, which is where you draw rectangles on what you want the computer to recognize, and then train the model on Google Colab. When the model has been trained, I deployed it on VS Code and it was ready to be used and tested. This is exactly why you make prototypes. By making this prototype, I've been able to see some of the problems I will encounter before going all in. The first problem, as you can see, is the code detecting things that are not sticker. It is detecting my phone right now as a sticker, which is not what I trained it to do. And the frames per second I was getting earlier before loading all of the program and the model into the code, I was getting about 30 frames per second, but now I think because of the complexity of the code, I'm now getting about 2 and 1 frames per second. And when the webcam is close to the stickers, it detects them well enough, but the moment you go higher, it does not detect any stickers. And I won't be bringing a whiteboard very close to the webcam. So these are the things I need to fix in the next model. I need to make sure when the webcam is far away, the stickers are detected. I will try to see if I can get the frame rate up from 2 to at least 10 frames per second, and to make sure it does not detect other things except the stickers. The previous model sucks for a couple of reasons. Number one, because I trained it with using just 30 pictures which I edited on Photoshop and not the actual pictures of the stickers. 30 pictures is kind of not enough to actually train a model and have it work really well. So, having learned from my mistakes, this time I'm going to be attaching the stickers to the board and take pictures of them, but I need a minimum of at least 200 pictures of each sticker. 4 stickers at each corners of the board, which will make at least 800 pictures in total. And to take 800 pictures, that is kind of hard. This is a code which takes input from a webcam and it turns the video the webcam captures frame by frame into a picture. So I plan to take pictures of the stickers using this webcam and this code. Took a total of 1,634 images just within 1 minute. And I did the exact same thing as I've done for the previous model, which is drawing rectangles on what I want the model to recognize. But because this is a lot of picture, it actually took me about 2 hours to actually complete the training for the model and get the data sets. model has now been trained and it has been deployed, but that was about 3 weeks ago. For the past 3 weeks, I've been fixing bugs and errors and things that are wrong with the code. But now all of the bugs have been fixed and the code runs normally as it should. Here is all of the code responsible for the success of this project. I cannot explain it all, but if you do want to check it out, it is going to be available on my GitHub page. Let's run the code now and see what this is capable of doing. This is what it looks like when I allow the model to draw rectangle and put labels over what it had discovered. But I had to remove that to make it look a bit more professional and clean. And now this looks much more professional. When you run the code, it takes a bit of time before it detects all of the stickers and initiates the whiteboard mode. And here we have the whiteboard mode. This looks great and it's just as I've imagined it to actually be. If you notice the right side, which is the original image being captured by the webcam, the whiteboard is actually being bent at an angle, but on the left side, which is the whiteboard mode, it returns it as a perfect 2D image. The rest of the frame you can still see in the whiteboard mode was intentional because you can actually cut out all of the frame, leaving only the whiteboard. I wanted to leave some background to make it look more natural, and because the example of the whiteboard mode I saw on the Insta360 webcam actually does the exact same thing, and I think it has some advantage to it. But if I want the whiteboard mode to show only the whiteboard, cutting out all of the rest of the frame, that can actually be done. The other thing you'll notice is it looks like the dimension of the whiteboard has been warped or it has been changed, but this can actually be fixed through some modifications to the code. And I can also make it such that the whiteboard mode will be initiated by a sign mode, a hand sign or hand signal, but I do not want to make this code much more complex than it needs to be, so I'm just going to leave it like this. But a lot of features and modifications can still be added to this and to make it more versatile and more efficient. The most impressive thing I found fascinating about this is everything is happening live. The prediction, the detection, and the calculation that actually returns the whiteboard mode, which is why I think I have gotten at least 2 to 1 frames per second, but it is okay by me. And by far, this honestly is a massive win on my book because I started this project with no experience whatsoever on computer vision, and I've actually been able to achieve this. And that's it for this video. If you liked the video and you've watched up to this point, please consider subscribing to support the channel. And if you need the code for this project as well as the trained model and the design pictures of the stickers that you can print out and actually attempt this project, it is going to be on my GitHub page. I'll put the link down in the description. Thanks for watching and I'll see you in the next video.